Now we're going to look at solving quadratic equations. Now quadratics we've already seen that linear has the power of 1, highest power equals 1, so that's the highest power, and with quadratics the highest power is 2. Here we've got all these examples here, the highest power is 2. All of these are example of quadratics, quadratic equations. You don't get x cubes or x to the power of 4, and indeed they won't be dealt with in this course, they'll be done in future courses. So we're only going to go as far as quadratics and then look at other types of equations that don't involve powers. And we're going to solve them. Now, first method we're going to use is solving quadratics by factorising. There are two methods, and both methods, the second method would always work. The first method will, by factorise, only works if the actual expression factorises. So the process to do it is, let's look at A for a starter. We've got x squared equals 36. You can see that the next two have got equals 0, and we tend to do that. We tend to put quadratics, if you like, a general way as ax squared plus bx plus c equals 0. They are examples or general way of writing all quadratics. You must have that term, you don't have to have that term, and you don't necessarily have to have that term. So as long as you've got something with x squared or the variable to the power of 2, that's our definition of what a quadratic is, it's still a quadratic. So here we've got c is equal to 0, is this B example, and here we've got all three, so that fulfills the general one. But this is still a quadratic. So what we've got to do is get that 36 over to the other side. So we take 36 from both sides, and we get x squared minus 36 equals 0. And when we did factorising earlier, we can see that this falls into a pattern, and we've got x squared minus what squared is equal to 0. What have you got to square to get 36? Well, the number 6, obviously. And you may recall that a squared minus b squared is a special, there's a special factorisation for that, and that's called the difference of two squares. These are both square numbers, and that's a minus b, a plus b. So what we've got to do here is our a is x and our b is 6, so that'll be x minus 6 times x plus 6 equals 0. And there is a thing called the null factor theorem. Null meaning 0. And that just says that if you've got two things, let's not use a and b, if you've got p times q equals 0, if you've got two factors or more that multiply together to give you 0, one of them has to be equal to 0. You don't know which one, but you know one of them has to be equal to 0. The only way when you multiply numbers together to get 0 is if one of them is 0. And that's the null factor theorem. So by the null factor theorem, you either know this one's 0 or this second bracket here is 0. So you're right, you don't know which one. Either x minus 6 equals 0. Now that's a nice little linear equation you can solve. Add 6 to both sides and you get x equals 6. So 6 will make that first one equal to 0, the first bracket, or the second bracket is equal to 0. And then we get x equals, take 6 from both sides, so negative 6. So if you put x equals 6 in the first equation, you want to do a check. 6 squared, 36. Negative 6 times negative 6 is also 36. So our answer is x equals 6 or negative 6. Now another way of writing that is plus or minus 6. That means it can be plus 6 or minus 6. That's just another way of writing that. X equals plus 6 or minus 6. Okay, let's look at the second one. Once again, it's a quadratic. It looks like that, but in this case, we've got that term and we've got that term. We don't have any constant term in here. So we've got x squared minus 3x equals 0. And we look for a common factor. Always look for a common factor. Are there any factors of x squared and 3x? Something that'll divide into both x squared and 3x evenly. Yes, x. Put it out the front. And you ask yourself, what am I going to multiply x by? What am I going to write here? So x, don't forget this x is going to be multiplied by that and that. The minus sign can come down incidentally and go in the middle. What am I going to multiply this x by to get x squared? Just another x. X times x is x squared. The minus come down. X times what is equal to 3x? So I've already got the minus down, so I don't have to worry about that. X times what is 3x? Well, that'll be 3. So once again, by the null factor theorem, either x equals 0, well that's easy, it's already solved, or x minus 3 equals 0. So this one, either that term 0 or that term 0. So x minus 3 equals 0, add 3 to both sides and you get x equals 3. So my answer here, x equals 0 or 3. If you put 0 in there, you get 0 minus 0, which is equal to 0. If you put 3 in there, you get 9 minus 9, you also get 0. Alright, so that's how to do the first two. The third one, C, and we might need a little bit more room, so I'll just write it out. X squared minus x minus 6 equals 0. So we're going to use factorisation. So we look at this here and we say, okay, we want to come up with two factors which when multiplied together are going to give us x squared minus x minus 6. To come up with those factors, these two multiply together to give you x squared. These two have got to multiply together to give me the last term, negative 6. Now, the only way I'm going to get negative 6 is if one of these is a positive and one of these is negative. And then when I multiply along here and add them together, I've got to get negative 1x. So I know that of the factors of 6 that differ by 1 are 3 and 2. So it's a matter of, do I put the 3 there and the 2 here? Or do I put the 3 here and the 2 here? And because I get negative 1x, I want the bigger factor to be down here with the negatives and that one there. Now when I multiply, just check. Multiply along there, I get plus 2x. Multiply along there, I get negative 3x. You always add the 2 and hopefully we're going to get the middle term here. So plus 2x minus 3x is negative 1x, which is just negative x, which is the middle term. So it's correct. So here is my factorisation. So instead of writing x squared minus x minus 6, I can put x plus 2, x minus 3 equals 0. Null factor theorem, either x plus 2 equals 0. How do I get x by itself? Take 2 from both sides and that gives me x equals negative 2. Or x minus 3 equals 0, add 3 to both sides, x equals 3. So my answer is x equals minus 2 or 3. Let's do a check. Left hand side equals x squared, so we're going right back to the original equation, minus x minus 6. Now you've got to do two checks here. So we've got x equals negative 2, you've got negative 2 squared minus negative 2 minus 6. equals. Now -2, when you square a negative you get a positive 4, minus minus is a plus. So 4 plus 2 is 6, minus 6 is equal to 0. And that's equal to the right hand side, because the right hand side up here is equal to 0. X equals, what was the other one? 3. So we got 3 squared minus 3 minus 6. 3 3s are 9. Take 3 from 9, you get 6. 6 minus 6 is equal to 0. So both of those are indeed solutions. So that's how to solve quadratics. Quadratics are generally of the form ax squared plus bx plus c equals 0. Here we didn't have it in that form, so we had to take the 36 over. And so we just had ax squared plus c. We didn't have any bx with this first one. And we just factorised using difference of two squares. And then we used the null factor theorem. Two things multiply together give you 0, and then one of those factors must be equal to 0. Same here, we look for common factors, always a good thing to take out common factors. So here we've got an x out the front, and then we can use the null factor theorem to come up here. And then finally we've got a trinomial here which has got 3 terms. It is a quadratic. We can factorise it using the cross method. You may be familiar with other methods to do that as well. Once again, we use the null factor theorem. Clearly display your answers, and you should check your answers to make sure you're correct as well.